Hello friends, welcome again. Today in this session we will discuss some advanced cases of oblique plane. In my last session I told you how to draw VTH of a oblique plane when alpha beta are known, or how to determine alpha beta when VTH is given. And I also told you how to convert an oblique plane into an inclined plane and auxiliary vertical plane. Now in this session we will discuss how do we determine the distance of a point from a plane. Distance of a point from a plane. Now let us take a very simple case first. That you have an inclined plane and you have a point A dash and A. Inclined plane and point A are given. What is the distance of this point from the inclined plane? And distance will be perpendicular from A to the inclined plane. So if you have an inclined plane like this and a horizontal plane, okay, if you have an inclined plane like this and a point here, that is the distance. And this distance you can measure in the vertical plane because this plane is perpendicular to vertical plane and this line is perpendicular to this plane. So perpendicular distance will be parallel to vertical plane. So if you drop a perpendicular here from this point, that means you are dropping a perpendicular from elevation on the vertical trace. The same. So if you drop a perpendicular here, let us say this is the A1. I call it A1. Remember, A1 is perpendicular to inclined plane. Then this is the perpendicular distance. That is the perpendicular distance of the point from inclined plane. This distance will be the same as this distance. Now this is also perpendicular. That is the. You drop a perpendicular, so you have an inclined plane, VTH, and a point here, A dash, A. Its distance from inclined plane is simply a perpendicular on vertical trace. Let us say B dash. A dash, B dash is the perpendicular distance. AB is a line. Now, AB is a line which is perpendicular to inclined plane. And I told you in my last session that whenever a line is perpendicular to a plane, its projections are perpendicular to the traces of the plane. And therefore, if you want to find out what is the plan of this point, this is the foot of the perpendicular. This point lies on inclined plane B. This point lies in the inclined plane. And what is the foot of the perpendicular B? What is the plan of this B? So plan of B will be here. Draw a line from A perpendicular to horizontal trace. So you get B. And again I would say this is true length only because this is parallel to ground. Go back to position of lines. When plan is parallel to ground line, elevation gives you the true length. And therefore this is true length only because this is this plan is parallel to ground. Similarly, if you have ABB, and a point here, either this side or that side, B dash B. Its distance from this plane will be a perpendicular from plan. Perpendicular from plan. Here. This is, let us say, C. BC is perpendicular distance. And this is perpendicular to plane, and therefore its elevation will be here. C dash. This line is perpendicular to vertical trace. When line is perpendicular to the plane, projections are perpendicular to traces. So that is how you determine distance of a point from inclined plane or from AVP. If the plane is oblique plane, then you convert that oblique plane either into inclined plane or into AVP to find out its distance. Let me explain this. You have an oblique plane, VTH, and a point. You can take point here, you can take point here. Let me take point here. A. Here you cannot find the perpendicular distance directly because it is not perpendicular to any reference plane. So what we do, you first convert this oblique plane into an inclined plane or into an AVP. Let me take a plane here. Let me take a plane here, AVP, and convert this into an inclined plane. This I told you in my last session, how to convert this oblique plane into an inclined plane. This is new vertical trace. And now plane is inclined plane, perpendicular to vertical plane. Project this point also on this AVP. So project this point also on this new x1, y1. And when you project it, you take the projection from the plan. So draw a projection from the plan, perpendicular, and take the distance of elevation. This distance. Here, from the ground line, that is A1 dash. Now consider this AVP. With reference to this AVP, oblique plane is an IP, and you have a point, elevation and the plan. This case, you have a VTH which is inclined to ground line and a point A dash and A. Instead of A dash, now you have A1 dash. So drop a perpendicular from A dash on this vertical trace. You get the perpendicular distance. Let us say this point is B1 dash. This is the perpendicular distance of the point from oblique plane. From oblique plane. Because oblique plane is already IP. Now, if you want to find out the projection of this foot of the perpendicular, this B is the point in the oblique plane and foot of the perpendicular. So, AB is now perpendicular to oblique plane, and therefore projections AB and A dash B dash will be perpendicular to traces, horizontal trace as well as vertical trace. So, from B1 dash, if you move perpendicular to ground line, back to our old ground line XY, and draw a line perpendicular to the trace, perpendicular to horizontal trace, you get the point B. Remember this, that from A you move parallel to ground line. Now ground line is x1, y1. So move parallel to ground line A, B. Parallel to ground line basically means perpendicular to horizontal trace. AB is perpendicular to horizontal trace. And from this point B, you again go perpendicular to XY to get the elevation, and from A dash perpendicular to vertical trace. Okay, so perpendicular to vertical trace. This is A dash. This is perpendicular to vertical trace. Remove extra line. So AB is perpendicular to HT and A dash B dash is perpendicular to BT. B dash B is the projection of foot of the perpendicular. Same exercise you can do by converting this oblique plane into an AB rather than into IB. But the point remains same. Projection will remain same. This will be the height and this will be the distance on the vertical plane. So that is how we determine distance of a point from a plane, whether it is inclined plane, auxiliary vertical plane or oblique plane. But in case of oblique plane, you convert that into either this case or this case. Now consider an oblique plane VTH inclined to both the reference planes and draw a line AB in oblique plane which is parallel to horizontal plane. A line CD in oblique plane which is parallel to horizontal plane. You can draw a number of lines. And I told you in projection of lines, whenever a line is parallel to horizontal plane, that means this height above HP and this height is same. Is same. So its elevation will be parallel to ground line. Okay? And all these lines are parallel. So all these lines A, B, C, D, E, F are parallel to HT. So plan will be parallel to HT. All parallel lines will have projections parallel. And therefore, if this is the vertical trace and horizontal trace of an oblique plane, then this is a projection of AB. AB. You can keep B point somewhere. A is in a vertical plane and therefore its plan will be here. This is a CD. CD. This is EF. These are called H parallel of an oblique plane. Lines drawn in oblique plane parallel to horizontal plane. And similarly, you can draw lines in oblique plane which are parallel to vertical plane. Like this. Okay? 1, 1, 2, 2, 3, 3. All these lines are parallel to vertical plane but in the oblique plane, and therefore their projections will be just reverse of that. Now the plan will be parallel and elevation will be parallel to vertical trace. Like this. These are called vertical parallel or V parallel. V parallel. X parallel and V parallel of an oblique plane are important to locate a point. So if you have a point here, let us say P, you can draw one X parallel and one V parallel through this point. And intersection of these two will give you the position of the point P. So if you draw a parallel like this, so you can draw the projection of the point. Let us say an oblique plane is given VGH and a point P lies in the oblique plane 20 millimeter above HP. Draw projection. So 20 millimeter above HP means elevation will be at 20 millimeter height. Okay. Now this is the X parallel. From this you draw. This is 20 millimeter. If you know, let us say 40 millimeter in front of V, 40 millimeter, then this is the point. This is the projection of a point P dash and P. It will lie in oblique plane. A point which lies on H parallel or on V parallel. If you draw a V parallel from this 40 millimeter, it will certainly pass through this P dash. So the H parallel and V parallel are important to locate the point in oblique plane. You can take one or two problems of locating points and try to solve. One more thing which I would like to explain here is a line lying in oblique plane. Line lying to horizontal plane or vertical plane and lying in oblique plane. So theta is given, oblique plane is given. Let us say you have an oblique plane and there is a line AB which lies in the oblique plane and it makes angle theta with the horizontal plane. AB, extend this line to HT and DT. Okay, A is here, B is here. If you know the length, fine. If you do not know the length, no problem. Let us say this point is P, this point is Q. P is the trace of the line. Okay, P is the vertical trace, Q is the horizontal trace. P is on vertical trace of the oblique plane. Now its projection on HP will be here. So this is, let us say, P dash, this will be plan. This is in the horizontal plane, so its projection will be on the ground. This is the elevation, Q dash. Okay, this is P dash, Q dash is the elevation of this line and PQ is the plan of this line. Okay. Now, how do we determine this angle alpha? What we do? Rotate this line and bring it in the vertical plane. So when you rotate this line, what you do, you rotate this point Q about 2 dash and bring it in the vertical plane so that you can measure angle theta. Angle theta. Now this is where you start in the projection. You have a plane VTH. Draw a line AB at angle theta from ground line touching the vertical trace. So this is the point from ground line to P at angle theta. Okay, this is the point here. Let me just put here P dash. Okay, and this will be plan. And this is a Q. Now Q is in the ground line, so plan elevation both will be on the ground line. Now we rotate this point Q so that it goes back to the horizontal trace. So that the complete line will now be in the oblique plane. So from P center and this distance, you rotate this line and bring it in. Okay. So this point is now Q, and its elevation will be Q dash. Now this is the elevation of the total line. This is the plan of the total line. Now this line is in oblique plane, inclined at 30 degree. Why inclined 30 degree with HP? See this. What is this? Elevation difference, and this is PQ sine theta. This you maintain here. PQ is the true length, total length, PQ sine theta. And when you maintain the elevation difference between P and Q equal to PQ sine theta, then you make angle theta with the horizontal plane. So that is how you draw a line, projection of a line which is inclined to HP and lying in the oblique plane. Similarly, you can do when the line is inclined to vertical plane and lying in the oblique plane. So in that case, what we do, you rather than drawing in the vertical plane, you can draw the line in the horizontal plane. So this is the vertical trace and horizontal trace. You draw a line here, you can draw any side, AB. You can draw here also. Okay? Condition is that one end should be on the ground line, the second end should be, and this angle is theta. True angle made by the, phi. This angle is phi, made by the line with the vertical plane. This is the point in the ground line, this is the point in the horizontal plane. Its elevation will be here, B dash. Okay, now you rotate this A and bring it in the vertical trace. So about B dash, you rotate this point and bring it here. Let us say C. Okay, this is C dash, and this is the plan C. This will be the plan and elevation of the line. Now we have considered here from one end to another end, but originally I told you line is AB. So if you know the coordinate of A and B, you can locate those points. Suppose you know that height of P is 20 mm or 40 mm. So take 40 mm here, this will be A. If height of A is 40 mm above HP, you can locate point A here. If you know the true length of AB, let us say 30 mm. This is the true length in the vertical plane. Measure 30 mm here, you get the point B. That is 30 mm. True length is to be measured only in the horizontal plane or vertical plane. So from this point, you draw a horizontal line and you get the point B dash. And once you know A dash, B dash, you can draw projectors and you can get AB on the plan. This is A, this is B. So A dash, B dash is the elevation of the line, AB is the plan of this line. But when you are drawing projection, you consider from P to Q, just for easy understanding. So that is how we draw projection of a line when it is lying in the oblique plane and inclined to either HP or BP. So friends, thank you very much for watching this video, and in this session we complete the topic of oblique planes.